called rates of change, which is another application of differentiation. So as long as you can differentiate, you can do the maths. It's just a matter of understanding what it's talking about. So the key idea here is that a rate has to do with time. So when we talk about a rate of change, we're asking how fast something changes, is really what the question is. So simple as that. So let's think of a example. So let's do temperature and time, rates of change. So this is going to be how fast the temperature is changing. So let's imagine that you've pulled something out of a furnace that was at 1,000 degrees and it starts to cool down. It cools down at a curve that looks something like that. And the equation of that curve might be something like T equals starting point, so 1,000, e to the minus 0.02 t, something like that. That would be a shape that would give a curve that looks somewhat like that. Okay, and so we can figure out at what time the temperature will be 50 degrees, at what time the temperature will be 900 degrees. We can work out the time. We could say at 55 minutes, what's the temperature going to be? We can do all those sort of things. But the question we really want to ask is, at what time is the temperature cooling down at a particular rate? So when is it cooling down at 5 degrees every minute? That's the sort of question we're asking with regards to rate. So what we need is we need an equation for the rate of change of temperature. So rate of change of, in this case, temperature. And this is equal to the derivative of the temperature with respect to time. So dt by dt, but one's a capital T and one's a small t. So how is the temperature changing as the time changes? So all we need to do is differentiate this sucker. So the rate of change of temperature is the derivative of this thing. The derivative of that thing is just an e. So we bring the power down the front and multiply it by 1,000. So we're going to get negative 20 being 0.02 times 1,000, e to the minus 0.02t. And then we can answer questions like, at what rate is the casting cooling 1 hour after coming, it starts with a C, not no, after coming out of the furnace? But that's an English question, we don't need all that rubbish. Okay, so now we're saying 1 hour, and I really should have been a little bit more precise over this side. I was a little bit naughty, that when I put T, I didn't tell you what the unit was. So we're going to say T is in minutes. Okay? And this temperature will go for degrees Celsius. So a well-framed problem should have the units on it. So 1 hour is not going to be any use. We need 60 minutes. So when we go to do our work, we're going to put in 60 minutes. So we can say that the rate of change after 60 minutes is equal to minus 20 e to the minus 0.02 times 60. And then from there, it's all just numbers, and you can punch away, push buttons on a calculator, and figure out what the actual value for that is. So let's check if someone's got a calculator I can borrow. Oh, awesome, thank you very much. We've got a calculator here we can use. So we're going to go with negative, I guess from there, there it goes, negative 20 times e to the power of negative 0.02 times 60 equals negative 6, almost exactly negative 6.02, but we'll go with negative 6. Okay. And the units for that, well, the temperature is in degrees Celsius per, and the time is in minutes. And the negative means it's cooling, which is what you expect. So we know that after 1 hour, the temperature will be dropping 6 degrees Celsius every minute. And that gives us an ability to figure out how things change, the rate of change. And we could ask a question that goes the other way. How long do you have to leave it until it's cooling at only 1 degree every minute, or something like that? If we want to just rearrange this equation, get T as the subject and go for it. Okay, so the key idea here is that when you see the rate, you need to think change with respect to time. Okay, so rate of change is always the thing differentiated with respect to time. That's what rate means.